We're on chapter 9, section 6, and we're going to talk about pKa. So remember when we talked about pH? Well, this is a very, very, very similar concept, right? We can use this term in order to compare acid strength. So is one stronger than another, right? And so when we talk about Ka, we know that's the equilibrium constant. And so P is the negative log, right? So you're just taking the negative log of the ability of the acid to disassociate. And so if you have a value that's closer to 1, that's going to tell you that you have a stronger acid. And so it's just easier to do this, to look at whole numbers instead of, 3.54 times 10 to the negative 12, right? It's just difficult to compare those numbers. And so when we convert it and we do the negative log of those crazy numbers, we get a number that ranges from anywhere between 0 and 60. And so the smaller the pKa, the closer it is to 1, then the stronger the acid is. So here's our pKa values. And what you can see here is that those who are up here at the top have values very close to 1, right? So phosphoric acid and hydrogen sulfate ion, those are very, very strong. Well, I say they're strong acids, but these are actually weak acids. These are weak acids, so we're really comparing the strength of weak acids. I know, kind of crazy, but if you look down here, right, the largest pKa value on this table is water. We know water can behave as an acid. It can also behave as a base. And so it's actually the weakest of the weak acids, and it has a pKa value of 14, right? So if you just kind of remember water's the weakest and it's 14, then you can kind of figure out the rest, right? And so if you look at our examples of our functional groups that can behave as acids, right? Acetic acid is going to contain a carboxylic acid, right? We have a carbon here that's double bound to an oxygen, and then we have another bond to an oxygen, and that's a hydroxyl group. And when you turn it in from acetic acid to acetate, right, we change that carboxylic acid to a carboxylate, which means we have lost the hydrogen and now we are negative. And so if we look at the pKa values of that, right, we get something that is 4.76. Well, if we look at our other functional group that can behave as an acid, that this would be a protonated amine, means we have an extra hydrogen on there, so that nitrogen is carrying a positive charge. When it loses one of these hydrogens, so we go from having 4 to having 1, 2, 3, we can see that we have a pKa value for this. So if you compare the two, which one is closer to water, which is 14, that's going to be the weaker. Which one is closer to 1, that's going to be stronger. So comparing these two, the acetic acid versus the ammonium ion, the acetic acid is a stronger acid than the ammonium ion, right? So all you're doing is comparing pKa values. So let's go do a couple of quick problems here. If you were to use this on a test, I would absolutely give you this. I'm not going to give you this arrow here. This arrow you have to remember, but I'll give you the table, right? All right, using table 9.8, determine the stronger acid from the following pairs of acids. H2PO4. So if we go find H2PO4, we get a value of 7.18. Or we're going to say versus HPO4 2 minus. This one is 12. So which one's closer to 1? So stronger, right? Stronger means closer to 1. So the stronger one is going to be the H2PO4. All right, H2SO4 or acetic acid. What should you notice about H2SO4? I have 2 more oxygens than hydrogens, so this is a strong acid. So acetic acid's a weak acid. You don't have to go and find the pKa values. You just go, that's a strong acid, it's stronger, right? Formic acid. Formic acid, if we go look on our table, it's 3.74 versus carbonic acid, which is 6.35. So that means closer to 1 is 3.74 or formic acid. Ammonium ion or hydrocyanic acid. So the ammonium ion is 9.21. Hydrocyanic acid is 9.2. I'm sorry, 9.2, this one's 9.20, this one's 9.21. So pick the one closest to 1. That is our ammonium ion. Okay, so even though they're really close, you have to pick one. All right, which is a stronger acid? Lactic acid, pKa of 3.9, or pyruvic acid, pKa of 2.5. Pyruvic acid, 2.5, right? So you have your pKa is closer to 1. That's your stronger weak acid, right? Okay, and that's it for that one. All right, have a great rest of your day.